What's up people, this is Vishal and I'm back again with another video. It's been long since I recorded anything. I've been sick, I've been busy, but I finally found time now, and in the next few videos we'll be talking about data structures in JavaScript, and today we'll be starting with linked list, and we will see how to create a linked list with JavaScript, and in the later half of the video we'll be solving a simple problem from Leetcode about linked list. So without wasting much time, let's go. So this video can go long because we are planning to do two things over here. First, we are going to make a linked list using JavaScript, and in the later half of the video we are going to do a problem solving question. So the people who are interested only in the problem solving question, you can skip the video to the time shown above, and rest of us, let's just look at how you will be creating a linked list in JavaScript. So looking at the screen now, so I've created a class over here called list node. So this basically represents the node of a linked list. So the node of a linked list is going to have a value and a pointer to the next element. Okay, so that's all we are going to do in the node. So don't worry about the export default that I'm doing over here. So this is specifically to maintain my code base, no other reason for that. The major part that you should be looking at is the class over here, and this class is taking a constructor with two parameters. Both of them are having a default value. So basically if I don't pass a value, that time the value will default to 0, and if I don't pass next, the value will default to null. Okay, so that's all about the list node, and now we will use this list node to create a linked list. So I've already created a file called linkedlist.js, and I'm importing my list node. Okay, so I've also created a class over here called linked list. You can also use a function.prototype over here. There is no compulsion of using class. Like I told you in one of my previous videos, that both the syntaxes are one and the same, and if you want to know how, just click on the suggestion box and check out the video on ES6 classes. Alright, let's proceed with the linked list class now. So we need to do a few things over here. So we'll be creating a constructor. Now this constructor is going to take one parameter, so I'll call it sequence. Okay, so this sequence is basically to initialize my linked list. So I'll be passing an array, and it should automatically be changed into a linked list. Okay, so we'll be doing that over here. Then I'm gonna have two parameters, this dot head and this dot tail, and both will be pointing to null. Okay, so this is very start of the linked list, and both my head and tail of the linked list will be pointing to null at this point. Now the sequence part, I'll come back to this. Let's just assign a default value as well to this, which is an empty array. So if I don't pass any value, basically it will be just an empty linked list where both head and tail will be pointing to null. Okay, now we'll come back to the constructor again, but let's make some helper functions over here first. So we'll be creating a function called append. So this function will be used to basically append an element into the linked list. So it will take only one parameter, which is the value that I want to append, and the next part is so with the new value that we have received, we'll be creating a new list node. So we already know the structure of the list node, so we'll be creating a new list node over here. So let's call const node equal to new list node and the value. Okay, so list node, whatever I pass over here, the value, it will be assigned to this dot val, and the next by default will be null because I'm not passing any value to that. Okay, which is exactly what we want with the new node, but it will only store the data, and the next of the new node is always going to be null. Okay, now if this is the first element in the linked list, that time the head is gonna be null, right? So we'll check if not head. So if the head is null, that time we are gonna do this dot head equal to this dot tail equal to node. Okay, so at this point when the list is empty, we are basically saying that both head and tail will be pointing to node and the new node that we created. And the else part, if the list is not empty, that time that means that the tail is already pointing to something, the head is already pointing to something. So since we are appending, we'll be moving the tail ahead. Okay, so the way we are going to do that is we'll say this dot tail dot next is equal to the new node, and the tail will now be pointing to the new node. Okay, so I'm sorry about that. Okay, so now the tail is now incrementing to the new location, and I'm also going to do one more thing over here, which is I'm going to return this so that I can chain the append function. So basically it is gonna look something like linked list dot append 1 dot append 2 dot append 3, and we'll be able to chain the functions. So regarding function chaining, I've already talked about in one of my previous videos. Again, click on the suggestion box and you'll get the link for that as well. Alright, so very straightforward. We are just whatever the value we want to append, we are just creating a new node for that, and if the head is empty, we are just basically assigning head and tail both to the new node, and if the head is not empty, means there are some elements in the linked list, that time we are just assigning our tail next to new node and then tail to the node, so that everything is in the sequence. Okay, now append is done, so we can look at this constructor again. So now we can simply write for let val of sequence. Okay, so we know that sequence, if we don't pass the sequence, it is going to be an empty array, so we can simply write let val of. So for of loop, we'll be using a for of loop over here, and it's, since we have already written the append function over here, we'll simply use that, this dot append, and whatever the value that we are getting from here. Okay, so that's pretty much doing my creating my linked list. For ease of execution, like for ease of checking whether my linked list is working fine or not, we'll also create a function to traverse through the linked list and print them onto the console. Okay, so actually I'll not create a function that would print on the console. I will create a generator function which would traverse through the linked list and yield the node that we are yield the node as it goes on. Okay, so we will create a generator function. So the way you will write a generator function inside a class is just write star, and I'll name this function as traverse. Okay, alright, so in the traverse function we need to be at head and move towards the tail. Okay, so all I'm going to do here is const, or we should use let, let's call it traveler equal to this dot head. Okay, so my traveler variable is now pointing to this dot head. So now we'll use a while loop. While there is something there in the traveler, we are going to yield the traveler. Okay, and as a part of the increment for the while loop, it will be traveler equal to traveler dot next. Okay, so that's pretty much my linked list. So now we need to import this linked list. So I've already exported this linked list out from this particular file. So I'll import this linked list into my index.js, and we will try to see if my linked list is working fine or not. Alright, so in my index.js, I've let me zoom in a bit. Yeah, in my index.js, I'm already importing the linked list. So this is, you can see it is pointing to the same class. I'll repeat again, you can create a function.prototype kind of syntax over here as well. The class and function.prototype are exactly the same thing, so don't get confused over there. So let's go back to our index.js, and we are already importing the linked list from at ds/linked list. So don't worry about all these things, they are just for my project structure. Now what we need to do with this linked list, so first let's try to solve a few things. So let's say const list is equal to new linked list, and I want a sequence of 1 2 3 4. Okay, Now, since this linked list is going to return me an instance of this particular class, now I can use my traverse function to basically traverse over the linked list and basically print them onto the console. Now what this generator is basically doing is, instead of defining what I want to do while traversing, like instead of defining, and let's assume that this linklist.js is a part of a library. Now instead of defining in the library itself that I am going to traverse and print on the console, I'm rather ejecting the value, and that value can be used by client whatever the way they want to use. For my use case right now, I want to console log them. So now since I'm using a generator, we can simply use a for of loop again. Let node of list.traverse. We are simply gonna do console.log, and it will be node.val. Okay, so we already know that list node is going to have a value .val, and that's what we are trying to access over here. Okay, now let me quickly run my dev server. So let's get this going. Let's close this out. All right, let's run yarn start. So this is going to start my dev server, and it is basically just going to execute this file, and we should be able to see the output in the console. So let's head on to the browser and go for localhost 9000. Okay, let's open our console, and in the console you can see that my traversal has completely worked fine. So I have zoomed in a bit so that you guys can see it. So here it is. So we are traversing and console logging. So the sequence was 1 2 3 4. We converted this array into a linked list, and then we are traversing over that linked list and console logging the values as 1 2 3 4. Okay, so we have tested our traverse, but what about our append? So let's do that as well. So I've already created a list with 1 2 3 4, linked list with 1 2 3 4. Then I'm gonna append 5 dot append 6. See how we are able to do the function chaining because of the one return this, right? So in my append function I've already returned this, hence we are able to do this kind of chaining. So again, append 7. So as expected, the output would be 1 2 3 4 5 6 7. So let's go back to our browser, and it auto refreshed, and you can see that my linked list is now having 1 2 3 4 5 6 7. So that basically creates my linked list. Let's also console log this list and see what it prints. So we'll do console.log on list, and let's head on to our browser and let's see what is there. So in my linked list, I had two variables, this dot head and this dot tail, which are directly accessible in the object. Right now, the rest of the functions, so the functions that I have created inside the class, so like I told you, a class is just a syntactical sugar on function.prototype, right? So internally class will always transpile into the same thing, function.prototype. Hence, if you open the prototype over here, you can see all the functions that are there inside the class are listed in the prototype. So just this is just for your understanding that these things, even if I write class linked list or function.prototype.append, function.prototype.traverse, it's basically doing the same thing. Okay, if I write it as function.prototype.append, it would do the same thing like you're seeing over here. All right, so let's now try to do the problem solving part. So the problem that we are going to solve today is the sum of two numbers problem from Leetcode. I'm not going to open Leetcode as such, but I'll give you the gist of the problem. So what this problem says is, let's just get rid of everything that is there in our index.js, and instead of importing my linked list, now I'll be importing my add two numbers file. So I've already created this file, and the definition of the function is it is taking 2 parameters. So according to this problem, so what it means is that we need to write the implementation of a function add 2 numbers, which is going to receive receive 2 linked lists. Okay, so let's see the example. So let's say I want to do this thing. So I want to do 342 plus 465, which is 807. So the output of this 807 would be printed as 708. So what this problem says is we need to perform sum of two numbers, 342 plus 465, and the thing that is known to us is the linked list of this number, the 342, will be created in this form, which is 2, 4 and 3, plus the other linked list is going to be 5, 6 and 4. Okay, so you can see that the linked list is created from the rightmost digit to the leftmost digit for both the numbers, and even the output is from rightmost digit to the leftmost digit, which is 708. So essentially we want our final linked list to have 708, but what we are basically doing over here is we are doing 342 plus 465 and 807. Now this is a known condition in the problem. Okay, so let's use our linked list. So let's use our linked list to create these inputs first. So let's do that quickly. Yeah. Alright, so let's use that linked list. We'll write const L1 equal to, we have already seen what input this linked list constructor will take. So we will pass in the same thing that we are passing over here, 243. So that will give us our first input. Okay, and for our second input we are going to pass in 564. Okay, and this will be L2. And what we need to do now is we need to hold the result of add two numbers, and the add two numbers is going to take input of two linked lists. So we'll be passing the heads of these linked lists to the numbers. Okay, so it will be L1 dot head. We already know that linked list object is having head and tail as two variables, so we'll be using L1 dot head comma L2 dot head, and the result is also going to be a linked list. So according to my understanding, I can just write while result. I'll quickly explain why we are using while instead of for off loop, which we saw in the first half of the video. The reason why we are doing this, because the way I'm going to solve this problem is going to be in the way you would be doing that on the Leetcode. Okay, so in Leetcode there is no linked list class available. We just have list node. Okay, so hence we cannot use the functions that we have written in linked list. Okay, so hence we are writing the while loop like this. So while result, so what we are essentially saying, as long as there is result, so we'll be returning the head of the result, and as long as there is a value over there, we are going to print it onto the console. So we will do console.log, and we will do result.val. Okay, so we know that result is going to have a list node, so we can simply do console.log result.val and result equal to result.next. Okay, so of course we need to change this to let. Alright, so essentially the output should be 7, one row as 7, 0 and 8, right? So let's now head on to add two numbers function and write the implementation. Now there are several things that we need to think about. Let me zoom in a bit. So right now we are passing both the numbers with same number of digits, right? So there is a possibility that one number is having more digits than the other number. That time the list will be longer compared to the other one, right? So we need to take care of that condition. That is the first thing. And secondly, since I'm not going to use the linked list class that I wrote in the first half, we are going to create the linked list in the function itself. Okay, so first things first, also the sum of two numbers, so any two numbers here over here, so from 0 to 9, the sum of two numbers is always going to give you a carry of 1. It cannot be more than 1, right? So because the max that you can do is 9 plus 9, which is 18, so the carry would be 1 always. Okay, so and the second thing is, once we do the sum of two digits, so we need to sum 2 and 5. Okay, so there is no carry in this. 5 plus 2 is 7, which is fine. Now 6 plus 4, this is where when we are doing the sum, right? So when we are doing 6 plus 4, we write 0 at the bottom and we carry the 1 to the top, to the next digit, right? So 4 plus 3 is 7, then we also have a carry, so that would be 8. Hence the result is going to be 807. Now notice that when we had a carry, we always took the first digit, right? So the unit place, and placed it over here. So we need to do a modulo. So always remember, so when we are doing sum of two numbers, we did a sum, we need the unit place. Now to do the unit, to get the unit place, we will always do a modulo by 10. Okay, so let's just try writing the code, and I'll basically explain on the go, right? So since I told you we are not going to use linked list, so linked list class that I wrote over here, so I'm going to create my own head and tail. So it will be head comma tail. Okay, so we have two variables, head and tail. I'll also create a variable called carry, which is initially 0, right? So initially my carry is always going to be 0. Okay, now since I told you that one list can be longer than the other, so the expression in my while loop would be L1 or L2. So the reason why we are doing L1 or L2 is there is a possibility that one list is longer than the other, and when we are traversing, we'll obviously move one node at a time, right? So there is a possibility that one of the lists reaches to the end while the other still has the elements, right? So that time we need to completely traverse so that we can do the sum properly, right? So we would do the conditions as do the expression as L1 or L2. If one reaches the end, we would still be able to loop over the second list. Now we will write the middle part later. Let's complete the traversing logic. So L1 and L2. So at the end of the loop, we will do L1 equal to, if L1 is present, right? So if L1 has a value, then L1 becomes L1 dot next. If L1 has become null, so it has already reached null, so that time we'll just return null. Okay, so this is the traversing logic, and same applies for L2 as well, right? So if L2 is holding a value, then the next iteration L2 equal to L2 dot next. If there is no value, so let's say L2 has reached null, that time we will just assign null to the L2. Okay, and in the second iteration, let's say if one list is longer than the other, then then L1 or L2 will still suffice the condition, and we would still be going inside the loop. So this is the first part. Now we need to do sum of two numbers, right? So we need to do const sum equal to L1 dot val plus L2 dot val. Okay, now there is the same gotcha that we saw over here, that one list can be longer than the other, would apply over here as well, right? So let's say L1 has reached the end and L2 still has values. So that time L1 would be null, so null dot value would be giving me an error, right? So that time for handling that scenario, I will move this inside parenthesis and write if L1 is present, then L1 dot val or 0. Okay, so if if L1 has reached null, that time we would just return 0, so that sum is not going to change. We need to do the same thing over here as well, so we'll move this inside parenthesis and we will write L2. If L2 is present, that time L2 dot val, or this is gonna return 0. Now this is the condition for sum of two numbers. Now there is one more thing that in this loop is gonna happen is once there is a carry. So we were looking at this input, right? So 6 plus 4 is going to give me 10, right? So in the next iteration, when we are summing 4 and 3, that time we should add the carry as well, right? So and we are only performing sum at the top of our loop, so we will just add carry as sum over here, add carry to the sum as well, because initially we are making sure that it is 0, and the way we are gonna calculate whether there is a carry or not is very simple. We'll just write carry equal to sum greater than 9. If the sum is greater than 9, then 1, else 0. Okay, so the reason why I'm hard coding it, because we know that max sum is going to be 9 and 9, so 9 plus 9 is 18, so it won't go more than 1, right? So we are simply hard coding it to 1, and if the sum is less than 9, that time obviously there is no carry, so we are just returning 0. So that in the next iteration when we are summing, that time carry will be 0 and it won't change the sum at all, right? So that's why we are returning 1 and 0. Alright, so this explains me the sum of the numbers. Now we need to create the list, the linked list, right? So we already have head and tail. Now we need to perform we need to create a linked list for the result. So first things first, we will create a node. The new node would be new list node, so we'll be using our list node that we wrote. Now the list node would be sum modulo 10. So we need the unit place of the sum, because the 10th place is anyway gonna be carry, right? So we need the unit place as the sum, which unit place of the sum, which is going to be a node in the linked list. So we are just gonna perform a modulo so that we get the unit place. Alright, so we have the node now. We will do the same logic that we wrote here for append, exactly same thing. There's nothing gonna change. So the conditions would be if not head. So let's say if there is no head, that time the head equal to tail equal to the new node. Alright, so this is my first thing when the list is empty. When the list has values, that time tail dot next equal to node. Okay, so tail dot next is node, and we need to make tail as node. Okay, so this is my linked list which is gonna get prepared. So we have head, let me reiterate again. So if it goes to the else condition, head and tail are both pointing to the same thing, then tail dot next points to the node and tail becomes node itself. Yeah, so that basically does my thing. Now there is one more gotcha, which is something which we won't get the idea in this particular input. So let's say is the sum of the last two numbers. So we are going from right to left, right? So the sum of last two numbers, that is 3 and 4. Let's imagine if it is 5 and 5, the sum of these two numbers is going to be 10, and the number of digits are going to overflow, right? So basically what I'm trying to say is the input 1 is 3 digits, input 2 is also 3 digits, but our output would try to become 4 digits. So we need to handle that scenario as well, where the sum of last two numbers is going to be more than 9. So and at that point, what would happen in my code is the sum of last two numbers is greater than 9. The carry has become 1. Now we made the linked list, we added a new node. Now L1 and L2 at that point both will become null. So our carry is still 1, but we have not created the node for that. So we need to handle that scenario as well. So once we are out of the while loop, we will put a condition. Okay, so we will put a condition if carry. So if carry is still there, so once the sum of all the digits has been done, we are basically checking for the last check whether the carry is still there or not. If the carry is still there, that time we are going to create a node with the carry, whatever the carry value is. For the this is definitely going to be 1, right? So carry is definitely going to be 1. You can directly write 1 over here, but let's just move ahead with the variable name itself. So const node equal to new list node, and we need to point our tail. So again, so tail dot next equal to node. Okay, and tail equal to node. So this is what we are going to do to handle that last use case where there is a possibility that some of the last two digits are going to exceed 9. Then we will have a carry, dangling carry, which is not gonna get handled by the while loop. Hence we need to separately handle that condition. Now at the end, we want to return the head of the node, head of the linked list. So we will just return the head. Okay, so we are just returning the head, and I think this should do it. So let's go to index.js. So result is now pointing to the head of the result, right? So the output of this input that I've given over here should be 708. So let's we have already written the traverse logic, so let's go back to our index.js. Everything is fine. Yes, so we will revisit the website again. I think it's hung. Yeah, so you can see that the linked list output is 708, which is exactly what we were expecting. Now let's test a few more scenarios. Let's say the last two digits is 6 and 4. Okay, so 642 plus 465. So let's say I want to perform this thing. So let's first see what would be the result of this. It is going to be 1107. So this is the final case that I was talking about, before which we wrote the additional if condition. So let's try it out if it is gonna work or not. So the answer for this was this. So the output that we would be expecting would be 7011. Okay, so this is the output that we would be expecting. Okay, so the input is going to be 246 and 564. Yeah, so the output should be 7011. So let's hit a refresh, and you can see 701, but notice that it is the one is being printed twice. So our result is basically absolutely right. Now let's test another scenario where the number of digits are more. So we have this and we have 99. So in this case, one input is having more number of digits while the other is only 99. For this kind of case, we wrote the L1 or L2 over here, and we wrote all these conditions, the ternary operators, to handle these kind of scenarios where one list has already reached the end while the other still has some values. So let's see what would be the output of this. Let's quickly do that in the console here, clear it up. We have 10098. So the result is 10098, and hence the expected order of my linked list would be 89001, right? So now the input is going to be 999 9 9, and here we will have 9 comma 9. All right, so let's head on to our browser, hit a refresh. You can see that we have 89001. So the reason you're seeing only 10 over here, because the console is truncating the console log. So you can see there is a 2 on the 0, so it is, our output is again correct, 89001, which is 89001. Alright, so I'm not going to again copy this thing and go to Leetcode and execute this. I've already done that over there, so it's just for your learning, so I'm not going to execute it over there, but basically this code is going to pass and when we execute over there. So that's the explanation for the problem add two numbers on Leetcode. And let's do one more thing, an additional thing. Since I've created a class called linked list, let's see how the solution of this code changes when I start using the linked list. So we will import our linked list. Okay, so we don't need to take care of creating head and tail anymore, because that will be taken care by my class. So I'm creating a empty linked list now. Everything is fine, so sum, carry, everything is fine. It's just that I don't need to perform all these things again, right? Because I've already taken care of writing that logic in my append function, right? So we'll be using the append function and solve that problem. So we don't even need to create a list node anymore, because linked list it is already importing the list node, so we don't really need to import that at all. So we just need the value. So all we need to do is result dot append, and we will pass the value over here. So no need of this. And L1 L2 everything is fine. We just need to handle this thing. So again, very simple, we will just do result dot append of carry, and of course, so instead of returning the head, we will return the result. Okay, so this is where you see the power of code splitting. So we modularized our code, we moved the entire linked list logic into linked list, and now the code, the core problem solving part that we were doing, is now more easy to read, and it's very small and crisp, right? So yeah, so that's my output after implementing the linked list class that we wrote in the first half. And now let's change, now that we are returning a linked list over here, right? So now we are returning a linked list over here, so we can use our traverse function. So I'll get rid of this part, and I'll go back to my for let node of result dot traverse. So now traverse is a generator, so I don't need to worry much. I can just do node dot val. All right, so that's my code after implementing the linked list class, and we go hit a refresh, our output is still the same. Okay, so I just wrote this because we had written the linked list class, and once we use the linked list class, this problem becomes more smaller and more crisp. Alright, so that's all for this one, guys. I hope you enjoyed this video. This is a pretty long video, so I hope you watched till the end. Please like and share this video with everyone who is aspiring to become a front-end engineer and is preparing for the interviews. It will be very helpful for them. And subscribe to my channel for more such interesting videos in the future, and hit the notification bell to get notified about my videos whenever I upload them. So see you in the next one.